Welcome back to eLearning, Day 2 of Unit 10. We are going to continue our investigation on inverse trig, mostly focusing on cosine and tangent today. Yesterday you were exposed to what inverse trig is, where we had to restrict the domain of a sine graph to make it one-to-one, which would allow the inverse to function. An inverse trig is where we put in a ratio and what comes out is the corresponding angle. And we talked about how sine, what I'm highlighting here, would have a principal interval of negative pi over 2 to pi over 2. So all the ratios that we put in, the corresponding angles that come out, will have to fit in between those values. Below are some practice problems that we did yesterday. Example 1 in English says, what angle has a sine of 1/2? There are many answers, but from our conversation yesterday, the only angles that fit in the principal interval would be pi over 6 or 30 degrees. For example 2, this says, what angle has the sine of negative root 2 over 2? There are many answers, as we stated before, but the only values within the principal interval are negative pi over 4 and negative 45 degrees. Many people will want to say 7 pi over 4 or 315 degrees, which do have sine values of negative root 2 over 2. However, these values do not fit in the principal interval, which is the reason they are not the result of this evaluation. So as mentioned earlier, today we are going to focus our energy on cosine and tangent. Well, cosine, the graph is presented right here, where we know this is a cosine graph because the output at 0 is 1, the output of pi over 2 is 0, and the output of pi is negative 1. So that's what I have highlighted. The restricted domain for cosine is going to be from 0 to pi, which is different than sine. Sorry. In sine, we went from negative pi over 2 to pi over 2. But that would not make a cosine graph one-to-one because we have repeated outputs, which is the reason our principal interval for cosine is highlighted in red, which would be angles of 0 to pi. This would cover any angles in quadrants 1 and 2 because they will represent all the potential outputs or ratios of any cosine value. In part B, the inverse cosine is graphed where the inputs are the ratio and the outputs are the corresponding angles. And this restriction allows the inverse to function. So my range would be 0 to pi. We can relate this back to parabolas when we were finding the inverse of a quadratic function. Because it wasn't one-to-one, or a parabola isn't one-to-one, we had to restrict part of the parabola so that we didn't include multiple outputs, and that allows us to find the inverse function, a square root, which allowed it to function. So just kind of relating back to that. So in our quick check, how I translate this math to English, it says, what angle has a cosine of root 3 over 2 within the principal interval? That's kind of the message you have to think in your head. All my answers have to be within the principal interval. Pi over 6, or 30 degrees, is the only angle that has a cosine of root 3 over 2 within the principal interval. I'm going to give you guys a moment to think about problem 2. What angle would have a cosine of negative root 2 over 2 within the principal interval? If you said 3 pi over 4, you would be correct. Again, there are many, many, many answers, but inverse trig must be within the principal interval. One way to remember what quadrants we're dealing with cosine, all of the angles will be within quadrants 1 and 2 because we have all the positive and negative ratios that are the result of taking the cosine of an angle. Sine, all the values, the result of doing inverse trig, would be between negative pi over 2 and pi over 2, which would be quadrants 1 and 4. So we can fill that in here, 1 and 2. So that's an investigation of inverse trig for cosine. Now let's scroll down and look at tangent. Looking at a tangent graph, we can see that this is not one-to-one because it fails the horizontal line test, meaning there are multiple inputs that have the same output. And we know that. There are many angles that have the same tangent value. This is the need to restrict the domain so that we have a function that is one-to-one, does pass the horizontal line test, accounts for all the potential values of the angle for the corresponding ratios. If I look at this graph, we could say that from 0, from 0 to pi, this interval does account for all the potential outputs of tangents. We have all the positives and all of the negatives. However, this isn't very consecutive because we have this asymptote in between the values. So it would make more sense to restrict our domain to be from negative pi over 2 to positive pi over 2. Let's not do that in highlighter. Let's go purple. Okay, so if we restrict the domain of the tangent function to be negative pi over 2 to positive pi over 2, which is like sine, now we have a one-to-one function. So we want to get rid of everything in red, just looking at the purple. So now when I graph the inverse function, it will function. So now all the inputs are going to be the ratios and all the outputs are going to be the angles. So just like any family or function that we've ever dealt with, when we talk inverses, that means the domain and the range switch, the x's and the y's switch. I will give you a minute now that we've talked about inverse trig for both sine and cosine. I'll give you some time to think about what is the inverse tangent of negative root 3. Negative 60 degrees, or negative pi over 3, are the only angles within the principal interval that have a tangent of negative root 3. Remember, inverse, I put in the ratio, I get out the angle. So question 2 says, what angle has a tangent of negative 1? So that is the result of evaluating. So again, this is just a reminder that when we're dealing with inverse trig, typically we put in an angle, get out a ratio. Inverse is reverse that. The principal interval for tangent is like sine, quadrants 1 and 4. So here's just an opportunity to have some practice with evaluating inverse trig and giving the results within the principal interval. When you see, like problem 1, it says cosine, it looks like it's cosine to the negative 1, that notation implies inverse, which is the same as saying arctan, like you see in problem 4. So arc or the script of negative 1 both imply we should be taking the inverse trig. Something that I always say in my head, I've written in green, what angle has a cosine of 1? I process. Oh, the result of that would be 0. I'm going to give you guys some time to practice 1 through 6, but I do want to talk about 7 through 12 before I give you that time. You'll see that there's multiple trigs, which these are kind of like compositions. We have multiple operations within this evaluation. Anytime you see arcsine or inverse with the negative 1, think angle. So problem 8 I've started for you. When it says arcsine negative root 3 over 2, that's talking about some angle. Can we evaluate that? Yes. What angle has an arcsine or has a sine of negative root 3 over 2? Negative pi over 3. So that's what I've put. That's this part. I evaluated. I get this answer within the principal interval, and now I look outside of that. It's saying, hey, take the tangent of this angle. So what's the tangent of negative pi over 3? Negative root 3. So 7 through 10, you can think of it as multi-step. Evaluate the inside, and then work outside. And then problems 1 through 6, this is just evaluating. Here's a ratio. Tell me what angle has the corresponding trig ratio. So I'm going to give you guys about, it should take about maybe 7 to 10 minutes to think, process, and then you can go on Canvas and check your results. Thank you so much for being with me today and investigating inverse trig. Bye.